Hello everyone, welcome to my channel Hypermesh Basic to Advanced. So to give a bit of a background about my channel, I make videos related to FE and Hypermesh. So if you are interested in these topics and new to my channel, consider subscribing to this channel. And if you are already a viewer and not subscribed, kindly consider subscribing as it motivates me to make more videos. Okay, so today's tutorial will be related to dynamic analysis. I've already done a tutorial on dynamic analysis, but this tutorial will be a bit different. We'll use LS Dyna solver in this. In the previous one, we had used radius solver. If you have seen that video, if you have not seen that video, you can just go and check it out on my channel. Okay. So this tutorial will be going to be more or less the same as the last one. The only difference will be some material values and the cards which we are going to use and the solver, right? So in this tutorial, what we will do is basically we'll have a rigid surface or a more stiffer surface, as you can say, and we'll have a softer element or surface or particle which will be colliding with this rigid surface as in the previous tutorial, right? Okay. So as you can see on my screen, the green part, it's the rigid surface or the stiffer surface. Okay, and this blue part, this is the softer elements which or particles which will be colliding with the rigid surface, right? So if I just I can just make it a wireframe view. So you can see I have created SPH elements here. These elements will be going and colliding with this surface, right? So what are SPH elements? If you want to know, I have given it in my blog post for this tutorial. I'll pin the link for this in the description as well as in the comment section, so you can go and check it out here, or you can just check out my previous video on the radius one and you will just find it, right? So what we'll do in this is we'll just go and create the mesh first, right? So as you can see, I have used quad mesh here for the surface. You can see this green color, right? You can just observe, right? Okay, and then I have used SPH particles for the element which are coming and colliding with this rigid surface, right? Next, so we have created the elements, right? So just in case you are wondering how to create the SPH element, for that you can go to 1D, which you can see here below geometry, okay, and then you can go to SPH, right? So the values I have used for creating the SPH element, you can see here the simple cubic I have put as 10, material density as 10, and I have used to create this SPH element, right? So we have created the elements, right? So next, what should we do? So we'll define the material and properties for these elements, right? So we can, for that, we can just go and right click on this white browser area, if you can see, and we can go to create and we can go to material, right? So like in the previous tutorial, if you remember, we had used different material for the SPH element and the rigid surface, right? Same way, we have used different elements for both. You see here, I have used mad power law plasticity for the rigid surface, right? So the value for that is as follows. You can take some other values, other material, right? It's up to your choice and you can just try it out. But for this purpose of this tutorial, I have used this value. So you can just use this value. If you want to see the values in detail, you can just refer to my blog post, link to which I will put in the description and in the comments. Okay. So this is for the surface green part, right? And then I've created material for the SPH element also, right? So the values are as this. One thing to note here is I have used the material none for this SPH element and material law plasticity for this rigid surface, right? Okay, so we we have created material, right? Next is what? Next we need to create properties. Okay, for creating the properties, we can just right click on the slide browser area again. We can go to create and we can go to section, right? You can see here just already created. So if you can see here, section is there. Just expand it, and there are two sections here. So one is for the SPH element, you can see here, and one is for the rigid wall elements, right? Okay. So the properties for the wall elements are as follows, and for the SPH elements are as follows. You can check out these values in detail in my blog post, right? So this is going to be a short tutorial, as this is more or less the same as the radios one, right? It's just that show you how to use this LS Dyna solver, right? So after this, we have created the mesh, we have created the material, we have created the property. Next what? So next, what we are going to do is we are going to assign the velocity to this SPH element, right? If you can just see here, here we have 4 SPH elements, right? So many, 1, 2, 3, 4, right? So we are going to assign values, initial velocity to this SPH element. So how can we do it? So before that, we need to create a set. Okay, as you can see, I have created a set here. Okay, if you see, there are 4 nodes, right? So these are the 4 SPH elements. I have created this set for it, right? So why I have done that? This is because we need to refer the set in the initial velocity, right? As you can see here, initial. This is the collector for the initial velocity. If you just expand it, you can see initial velocity generation, initial velocity, and we have referenced the node setting, right? So here in this tutorial, I have given a velocity of 150 and the negative z direction. So you can give any velocity according to your choice, and you can observe the change in this your analysis result, right? Okay. So next we have given the property, material, and the velocity to the SPH element. So what is next? So next we will create the contact. So we are going to create the contact. So why is the contact needed? So since these two objects are coming and colliding with each other, we need to define the contact. Okay, if they are coming in contact, we need to define the contact. So for that, I have already created a collector here. You can see contact, right? So we'll go to contact. We can just expand it. Contact automatic nodes to surface. Why nodes to surface? Because the SPH are nodes here. They are elements, but we are using this one, nodes to surface. So as you can see, I have given slave and master ID here. I have given these values, right? So you can check out these values in my blog post. It will be there. Link I will give in the description, as I said before, right? Okay. So we have created the mesh. We have the property in place. We have the material in place. We have the velocity in place, and we have the contact in place. So what is next? So next, what we will do is we will constrain this wall in space, right? So now it's not constrained. For that, you can just go to boundary. As you can see, I have created here boundary SPC nodes, right? So here hidden, so I can just review, right? So you can see I have constrained the edges of the screen surface to constrain it in space, right? Okay. So we have the mesh, we have the material, we have the property, we have the contact, we have the velocity, and we have the constraint, right? So what is next? So next we need to define the control cards, right? And the database card. And before that, I forgot to say one thing. We have to define this EOF, right? So what is EOF? I'll make a separate tutorial or a separate post on this, right? In my website. So there are some things which need to be which have to be given in detail. So I'll make a separate post for this. But for the time being, we need this card, since we are going to put this in this SPH element that we have created, right? if you can just see here, we have referenced it here in the USID, right? Okay, so I'm going to explain this in some upcoming tutorial or in my blog post. Okay, so for the time being, you just understand that we have used this UF here. Okay, so the values for this is like this. Okay, so you can refer to my blog post for this also. Everything, all the values are there in my blog. Okay, so fine. So we have the mesh, we have the element, property and material, we have the velocity, we have the contact. So we have to create the control and database card. So as you can see, I have already created the control card. So control termination. So this is for terminating the run, right? So I have given the end time as 10, right? And control energy I have given as 2 for all the fields, right? You can use this. Then control SPH I have given 3 and 0 for this. Okay. So next we are going to use database. So database options I have used as these all the values which I've used for the database, right? So you can just check it out in my blog post as I told before. Then DB plot. So this is what I've used here. Anyway, I've explained these things in my previous tutorial and the radiophone. I think the cards are more or less same, and some cards might be different. So you can check that video out to understand these in detail, or if there is a requirement, you can tell me in the comment section. I'll just make a detailed post on this, or try to make a detailed video on these things, right? Okay, so what we have now is we have the mesh, properties, material, initial velocity, right? The constraint and the contact surface, the cards, right? So we have created everything, right? So now what we can do, our model is ready for export, right? So before that, we just delete this surface before exporting because we don't need this, right? We'll just delete this surface. You can see, yeah, okay. Just click on return. Okay. Then we can export this, right? So for that we can go to this. If you can see here, export solver text. You just click here. Then select the file type as LS Dyna. Then template keyword R10. You can select according to your LS Dyna version, right? So I have R10. So I'll select that. Then we can give the name of the file here. Okay, so I'll give this file something else. Okay, so I'll just name this file as 1. Okay, so LS Dyna. Okay, so once we have exported the K file from Hypermesh, we can just open the LS Dyna solver. As you can see here on my screen, we need to select the input file, that is the K file, right? And the solver file, and then we just need to click on this run button. Okay, then it will run, and as you can see here, the status will be shown here. So if you can see, I've already run the file. So status shows finished, normal termination, right? That means it ran without any problem. Okay, so next we'll go and just check out the results in Hypermesh, right? The D3 plot file in the results, right? And then we can just click on apply, and it will open the model with the result, right? So if you can just see on my screen, so this is how the result is looking. If you can see, the stress plot for the wall is varying. If you can see, if you can just observe the variation, how the colors are changing, right? If you can see on my screen here, you can just notice here. I'll just zoom here if I can. Right, you can see these white dots here, right? So these are the SPH elements, I just move it in time, how they are moving, right? Right? We can just see it. So we can just see the stress, strain, velocity, displacement, all the result. What do you want to see here? Okay. So this is basically how we can run a dynamic analysis in LS Dyna. So it's more or less same as the radius part, right? The basics you mentioned, right? It's only some solvers, materials, and properties, and the control cards which can differ, right? Okay. So this is all for this tutorial. Hope you got to learn something new from this tutorial. Okay. And I have not been making videos for a while now, so I was a bit busy. So now, since I've started again, I'll try to make videos more frequently, right? And one of the persons has requested for a hyperview tutorial, so I'll be creating that too. Okay. So this is all for this video. See you all in the next video. Please like, share, and